the quantum computer, we are discussing that what are the qubits and how the qubits are used single as well as the multiple form. And in the classical we use the Cartesian product, but in the quantum we use the tensor product. So now further in this series we discuss about the quantum computer circuit model, then how this work. So quantum computational consists of first the initialization of the n qubit register, that is defined by the phi. You can see that here the psi symbol is here. So quantum state transformation of register is another part. Another is a sequence of primitive, means 1 or 2 qubits operation that use the gate, that is defined by the U, that collectively perform the transformation of the register. So first initialize the n qubit register, then quantum state transformation of register, that register perform collectively by using the gates and the sequence of primitive like 1 and 2 qubits. So measurement, another is a measurement of sum of all the qubits of the register will takes place. After that classical control throughout to program which quantum steps to carry out. Then next is the intercept result of the quantum measurement. Means what are the interpretation of the result of the quantum state. Now you can see they are the ways register and how they are attached and they are performed collectively. So you can see through the tensor product they are working together in a multiple manner. You can see U1, U2, U3 and U4 are the various registers that are used in the quantum computing. As we talk about the notation, we are using the qubits. So basic notation has been taken from the Dirac notation, that are the bra and ket. So true component, that is bra and ket, that is defined. You can see here the arrow on the left hand side, now in the ket arrow on the right hand side. A row vector, that is the adjoint, and the ket is the column vector. Psi means here we are having the bra as a row vector and ket as a column vector. Now we can see the table that here we are having the table. You can see here the 0 represented by 1 0. The label, for example psi, is merely a name and has no inherent meaning. Like however the some conventional exists are, you can see 0 can written as 1 0 and 1 written as 0 1. And plus if we take in is the ket, it will be 1 by root 2, then it is 1 1, that is a modulus we are taking that here. Now here it is represented by 1 by root 2 1 1 and here 1 by root 2 1 minus 1. And finally that is written in the, these are written in the row, then written in the column also. So these are the bra times ket means psi into phi, and then inner product written as a scale. Now if we talk about the ket time bra, so phi psi, that is written as the arrow in between the phi and psi, and then it is a outer product as well as a written in the matrix that we have taken from the quantum physics. So ket and bras, that can be written as A B is an implicit tensor product, that you can see here. How can we written as A into B? We routinely now we have even the further adjust A B for the simple cases. Given the two orthogonal kets, that is one up and another is down, that are each normalized, that can be typically written as, you can see easily, minus up and down, that is equal to 1. And if 1 up 1 down is equal and 1 is equal to 1 down 1 up is equal to 0. So these are the 1 and 0 qubit system that has been taken from the bra and ket. So we are having a two orthogonal ket, one is up, one is down, that are each normalized and then typically written as up, both are up, both are down, that is the one. If one up, one down, or is equal to another up, another down, then it equal to 0. So convenient way to reason about linear transformation. So out, in, out means 0, in means 1, and is as operator that maps into out, right, by the left multiplication and anything orthogonal to the into 0 vector. Out in is equal to out, or out in out is equal to 0, and if in up, out. Then we can see distribution properties we can also have. For example, assuming now x and up y and x mod y mod is equal to 1. If this equation, then we are having a x into 0 minus I y. If we talk about distribution property, then finally we are having the last equation. You can see a b c into, that is a tensor multiplication, c d is equal to a into c, b into d is equal to ac b d. Now this is the circuit diagram for the quantum computing. You can see 0 0 and hy, that is defined as the qubit number 0 1, that will be the, and with respect to the time it will enter into the system. Now the circuit model of the quantum computing, that has been defined. The label box represent the single qubit operators, like here we are having a single qubit operators 2 cross 2. Symbol, vertical line symbol represent a 2 qubit operator 4 cross 4. Single line here you can see that these are the 4 cross 4 qubit system. Now a quantum circuit is really just a piecewise representation of an enormous unitary matrix 2 power n for the n qubit system. Now this is the basic circuit. You remember that when we talk about the digital circuit, then we prepare this with the bits and time. These are the logic gates we use whenever we just make the circuitry in the classical computers. So this is analogy to classical digital circuit, that we will use AND and NAND gate. This is the bits and time, but in case of the qubits we are using the registers, and that has been defined in this form. Time, and basically multiple registers are connected with each other. So these are T, T, H, T1, Ts. So basic circuit model concept, if we talk about it, analogy to the classical digital circuits, what are the difference between these two circuits are, quantum circuits must be reversible or and same number of inputs and outputs for each gate and for the circuit as a whole we can take. So only computational, not sequential logic we can take. What are the key points of this? Abstract model of the operators to be applied, software not the hardware. A qubit states can be considered as a point on the unit sphere. The qubit states can be considered a point on the unit sphere. Programmers explicitly control the quantum effect. So what are the two effects? That are the superposition, another is the entanglement. So superposition, this qubit should be rotated by this amount in this direction, that is a superposition, how the qubits are rotating, how the qubits are attached with the another qubit. And another is the entanglement, that is loosely this qubit should conditionally rotate that qubit, means there must be relation between the one qubit with the another qubit. First, amount in the direction where the qubit is rotating, another is the conditionally rotate the qubit in a relation, that one qubit is rotating and another will be rotating, how will be related to the previous one. As I have given the example of the coin that has been thrown. and head, and moreover we can have the one head and we are having a one tail. So there is a probability when we throw it, then one head or tail, but in the air there is a number of probability of the head and tail. So similarly here, if we represent in the 3 dimension, that has been defined as a polarization gradient like x, y, x, z. Now the quantum mechanics is a bit like the operating system of the universe. A computer that uses the quantum mechanical principle to process information has certain advantages in the modeling physical system. So therefore, quantum computing is of particular interest for the chemistry and the material science applications. Quantum computer might help researchers seeking useful molecules for pharmaceutical or engineering application identify the candidates more quickly and efficiently. Quantum computers can also process data by using the mathematical techniques not accessible to the classical computer, by using the quantum mechanics. So that means they can give the structure to the data and help discover the pattern that classical algorithm alone might miss. So in practice, this might be useful for application ranging from biology, for example biology to finance, and moreover there is used for the data storage and many other applications. We use the quantum computing, and for the fast processing, moreover the efficient manner, we can have the calculation in a efficient manner or in a very fast manner. So they are the 4 principles of the quantum mechanics that must be used whenever we talk about the quantum computing. When discussing the quantum computers, it is important to understand that at the smallest scale, the universe behaves very differently from what we are used to in our day-to-day lives. So we are talking about the smallest scale. And whenever we talk about the quantum, we are talking about the scale at the atomic and molecular size, that is the smallest scale. These scales are different from the daily life, and compared to what we learn in the grade school physics, so behavior of the quantum objects are often have the different formulas as compared to the classical physics. So describing the behavior of quantum particles present a unique challenge. So most common sense paradigm for the natural world lack of the vocabulary to communicate the surprising behavior of the quantum particle, but the quantum mechanics reveals how the universe really works. As we talk about the particle of the atomic size and what are the behavior of this particle, so quantum computers take advantages of quantum mechanics by replacing the traditional binary bit circuits with quantum particles, that are the quantum bits, and that is called the qubits, and these particles behave differently from the classical bits and exhibiting the unique properties that can be described only with the quantum mechanics. So to understand the quantum computing, it is important to understand the 4 key quantum mechanics principle. Number 1 is the superposition, second is the entanglement, third is the decoherence, and fourth is the interference. So in the superposition as in the qubit, it is not very useful, but it can place the quantum information it holds into a state of superposition, which represent a combination of all the possible configurations of the qubit. It means whenever we talk about all the configuration, we are talking about the superposition. So group of qubits in superposition can create complex multidimensional computational spaces. Complex problems can be represented in a new ways in these spaces. So when a quantum system is measured, its state collapse from a superposition of the possibility into a binary state, which can be registered by binary code as either as 0 or the 1. Another important factor is the entanglement. So entanglement is the ability of the qubit to correlate their state with the other qubits. So whenever we are having a multiple qubit, it means there must be a correlation between the two qubits. So entangled systems are also instinctively linked that when quantum processors measure a single entangled qubits, they can immediately determine the information about other qubits in the entangled system. So when they are related to each other, they can pass a information. One qubit can pass information to the another qubit in the entangled system. Third point is the inference. Interference means interference is the engine of the quantum computing, an environment of the qubit placed into a state of the collective superposition structures information in a way that look like a wave with the amplitude associated with each outcome. Means it is works as we talk about the superposition. So all the superposition structure must be collectively stored in it, and it behaves like a wave and amplitude associated with the outcome, and these amplitude become the possibilities of the outcomes of the measurement of the system. So these waves can build on each other when many of them peak at a particular outcome or cancel each other out when the peaks and troughs interact. So like in the superposition, when the multiple having the maximum energy, they just superimpose each other, and when they have a minimum, then they are just cancelled to each other. So amplifying a probability or cancelling out others are both forms of the interference. Another is a decoherence. Decoherence is the process in which a system in the quantum state collapses into a non-quantum state. I mean, once a system is in the quantum state but it collapses and it reaches in the non-quantum state, then it is a decoherence. So it can be intentionally triggered by measuring a quantum system or by other environmental factors. Sometimes these factor triggers is unintentionally. So generally speaking, quantum computing requires avoiding and minimizing the decoherence. Decoherence means decoherence we don't require, so we have to keep in mind. So what is a decoherence? When the system, if it is system is in the quantum state and it just go into the non-quantum state, so we avoid to be this gesture whenever we are talking about the quantum computing. So we avoid as well as we minimize the decoherence. So these four factors are important. First is superposition, second is the entanglement, third is the interference, and fourth is the decoherence. So all are important in the quantum computing. So how the principle work together? As to better understand the quantum computing, consider that the two surprising ideas are both true. The first is that objects that can be measured as having definite states, means qubits in the superposition with defined probability amplitudes, behaves randomly. The second is the distant objects, in that case entangled qubits, can still behave in a way that through individually random or strongly correlated. Again the two principles, first is the superposition, second is the entanglement. Superposition means qubits are probability having the best random amplitude, and second is the entanglement, that define the relation also. So computational on a quantum computer works by preparing a superposition of the computational state. A quantum circuit prepared by the user uses operation to entangle qubits and generate the interference pattern as governed by the quantum algorithm and avoid the decoherence. So many possible outcomes are cancelled out through interference while others are amplified. So amplified outcomes are the solution of the computation. So amplified will be used in the computation. So these are the basic requirement of the you can say the quantum computing. So we can discuss about some of the advantages and disadvantages of the quantum computing. If we talk about the advantages, speed is the first advantage. Quantum computation are the fast and they allow solving the some problems in considerably less time than the present available classical mechanics. It means quantum mechanics runs faster than that of the classical. Another is a quantum computer can run large scale data problems faster than that of the classical computer. And third is solving the new problems. Quantum computer can solve the problems not solvable by the classical mechanics, and that can open the classes of the problems that cannot be effectively represented and calculated using the binary approach. Drawing is similarly to the mechanical engines, the mathematical implications. Most of the problems we can solve by using the quantum and enhancing the quantum classical computers. Quantum computers are complementary to the classical computer. Now, memory density, if we talk about the memory density, entangled qubits can represent the problems that cannot be represented in the binary computational space. Entangled qubits have more than the 2 states. So, instead of rising linearly like the information in the classical memory, qubits rise exponentially. So, it only takes a relatively few qubits and even fewer qubits to perform the complex algorithm that exceed the capability of the conventional computers. Another is a novel approach to solve the problems. Quantum computers allow for a new way to view the problems because the new technology, new approaches to solving the problems are needed and becoming the available, and the progress takes place when new ways to view the problem present. Need of, but there are the some disadvantages also. Need of the supercooling. So qubits that presently make up quantum computers require the temperature near absolute zero. Such temperature is extremely hard to generate and maintain. Another is the cost. Supercooling requires a specialized equipment and the power maintain the computer requirement operation environment. So supercooling coupled with use of the exhaustic material to construct the various qubits, processor and interfaces that makes the quantum computing very costly. So another problem is the thermal errors. Just running a quantum machine can cause the thermal errors to be present in the result of the calculation. So decoherence is another problem, means we cannot go from the quantum to non-quantum system. So that is also the one of the disadvantages. Now so lack of trained user. Nowadays we are in under the development and we are developing these computers, and nowadays initiation has been taken from the government just to train the people. So in the future we get the trained people regarding trained student for the for this quantum computing, right. From this the quantum computing, in the next lecture we discuss the quantum algorithm and how these algorithms work in the quantum computing and how they are related to the fast processing. So up to now, thankful to you. Thank you very much.